Q6976 to help prevent overturning when taxiing light tricycle-gear airplanes, especially high-wing type. In strong quartering tailwinds, the A. Elevator should be placed in the up position. B. Elevator should be placed in the down position. C. Aileron on the downwind side should be placed in the down position. The correct answer is B. To help prevent overturning when taxiing light tricycle-gear airplanes, especially high-wing types, in strong quartering tailwinds, the elevator should be placed in the down position. When taxiing in strong quartering tailwinds, there is a risk of the wind getting under the wing and causing it to lift, potentially leading to an overturning moment. To counteract this effect, the elevator should be placed in the down position. By placing the elevator in the down position, the pilot increases the downward force exerted on the tail of the aircraft. This helps to keep the tail firmly on the ground, providing better stability and reducing the risk of the wing lifting due to the strong tailwind. Q6977. Which aileron position should you generally use when taxiing in strong quartering headwinds? A. Neutral. B. Aileron up on the side from which the wind is blowing. C. Aileron down on the side from which the wind is blowing. The correct answer is B. The reasoning behind this answer is to minimize the effects of the wind on the aircraft while taxiing. When there is a strong quartering headwind, it means that the wind is blowing from an angle in front of the aircraft, coming from one side. By using aileron up on the side from which the wind is blowing, you are effectively raising the aileron on that side, which creates more lift on that wing. By increasing the lift on the side where the wind is coming from, you can help counteract the tendency of the wind to lift the downwind wing and push the aircraft off course. This technique, known as aileron into wind, helps maintain better control and stability during taxiing in strong headwinds. Overall, using aileron up on the side from which the wind is blowing helps to keep the wings level and prevent the wind from adversely affecting the aircraft's direction of travel while taxiing. Q6978. When taxiing with strong quartering tailwinds, which aileron position should be used? A. Neutral. B. Aileron up on the side from which the wind is blowing. C. Aileron down on the side from which the wind is blowing. The correct answer is C. When you have strong quartering tailwinds, it means that the wind is blowing from behind the aircraft at an angle. In this situation, using aileron down on the side from which the wind is blowing is the appropriate technique. By applying aileron down on the side from which the wind is coming, you are effectively lowering the aileron on that side, which reduces the lift on that wing. This helps to counteract the effects of the tailwind, which tends to push the aircraft forward and increase its speed. Using aileron down on the side from which the wind is blowing helps maintain control and stability during taxiing in strong quartering tailwinds. It helps prevent the wind from lifting the upwind wing and reducing traction on the tires, which could result in a loss of control. By adjusting the ailerons in this manner, you can better align the aircraft with the direction of travel and reduce the risk of the wind affecting the aircraft's stability and control during taxiing. Therefore, using aileron down on the side from which the wind is blowing is the correct technique to employ when taxiing with strong quartering tailwinds. Q6979. Why should an airplane be headed into the wind for the pre-takeoff check? A. To prevent the need for more brake pressure to keep the airplane from moving forward. B. To obtain more accurate operating indications and to minimize engine overheating during run-up. C. To prevent excessive load factors which could occur during run-up if a crosswind condition exists. The correct answer is B. Heading the airplane into the wind has several benefits during the pre-takeoff check. One of the key advantages is that it allows for more accurate operating indications. When the aircraft is facing into the wind, the airflow over the various instruments and sensors on the aircraft is more representative of the actual conditions during flight. This is important because certain systems, such as the airspeed indicator, altimeter, and vertical speed indicator rely on the accurate measurement of air pressure and airflow for their readings. By aligning the aircraft with the wind, these instruments can provide more reliable and accurate information. Additionally, heading into the wind helps to minimize engine overheating during the run-up. During the pre-takeoff check, the pilot performs engine run-up procedures to ensure that the engine is operating correctly and that all systems are functioning properly before takeoff. Running the engine at high power settings generates a significant amount of heat. When the aircraft is facing into the wind, the airflow helps to dissipate this heat more effectively, reducing the risk of engine overheating. This is particularly important in warm weather or high-altitude conditions where engine cooling is crucial for safe operation. Therefore, heading the airplane into the wind for the pre-takeoff check provides more accurate operating indications and helps minimize engine overheating during run-up, making it the correct choice for this scenario. Q6989. When explaining the techniques used for making short and soft field takeoffs, it would be correct to state that A. During soft field takeoffs, liftoff should be made as soon as possible. B. During soft field takeoffs, liftoff should be made only when best angle of climb speed is attained. C. During short field takeoffs, liftoff should be attempted only after best rate of climb speed is attained. The correct answer is A. When making a soft field takeoff, the goal is to minimize the amount of time the aircraft spends on the soft surface, such as grass, gravel, or an unpaved runway, in order to reduce drag and maximize performance. Soft surfaces can create additional drag and resistance, making it more difficult for the aircraft to accelerate and lift off. By lifting off as soon as possible during a soft field takeoff, the pilot can reduce the amount of time the aircraft's wheels are in contact with the soft surface. This helps to minimize the drag caused by the surface, allowing the aircraft to accelerate more effectively and achieve a higher rate of climb. Additionally, lifting off early in a soft field takeoff allows the aircraft to rely on the lift generated by the wings rather than the ground effect, which is the additional lift experienced when the aircraft is close to the ground. Ground effect can be diminished or disrupted by the soft surface, so it is generally more advantageous to transition to relying on the wings for lift as soon as possible. Therefore, during soft field takeoffs, lifting off as soon as possible is the correct technique to employ in order to minimize drag, optimize performance, and maximize the chances of a successful takeoff from a soft surface.